senior high school students of Kawayan City National High School. For today's video lesson, we will talk about percentiles using t-distribution. Remember that a t-distribution is like a standard deviation. The curve is symmetric approximately to the mean, and the total area under the t-curve is equal to 1 or 100%. It is likewise bell-shaped like a z-distribution. However, the values in t-distributions are more spread out around the middle, which makes the curve shorter and flatter around the center. The t-distribution is used when the sample size is less than 30 and the population variance is unknown. If the sample size is increased, the t-value of the percentile decreases. Key facts about percentile. The 2.5th percentile of the given variable means that the value of the variable that has an area to the left of 2.5 or 0.025. Dictionary.com defines percentile as one of the values of a variable that divides the distribution of the variable into 100 groups having equal frequencies. MarketBusinessNews.com describes percentile or centile as a value of the number that represents a percentage position on a range of the list of data, the person or things at the number of values in is above the number in percentage. According to statistics by Gym.com, it is the percentage of scores that fall below a particular value. They can tell you where a score stands relative to the other scores. Percentiles are a great tool to know the relative standing of a value. Let's have an example. What is the 10th percentile of the t-distribution when the sample size is 6? Let's consider the chart. The 10th percentile is found in some place in the lower end tail of the left side of the zero. The 10th percentile is the value where 10% of the quantities lies underneath it, and the 90% lies above it. It likewise implies that 0.10 is the area to the left of the 10th percentile t-value, while the 90th percentile is located somewhere in the upper end tail of the right side of 0. The 90th percentile is where 90% of the quantities lies underneath it, and the 10% of the quantities lies above it. This means that 0.10 is the area to the right of the 90th percentile t-value. Since the t-distribution table only appears at the right tail area, if the percentile lies to the right of the mean or above the 50th percentile, the area to the right of the given percentile can be found by subtracting the percentile from 100% or 1. The area to the left of the 10th percentile t-value is equal to the area to the right of the 90th percentile t-value. This means that the 10% percentile of the 90th percentile have the same t-value of the t-distribution table. Let's have the solution. First step is to list the known facts of the problem. That is, 10th percentile, n is equal to 6, degree of freedom or df is equal to n-1, that is 6 minus 1, that is equal to 5. So we have the value of our degree of freedom. Second step, find the area associated with the percentile by dividing it by 100. That is, 10 percentile is 10 all over 100, which is equal to 0.10. Third step, identify if the area of probability is higher or lower than 0.50. If the percentile is higher than 0.50, subtract it from 1. Since 0.10 is lower than 0.50, there is no need to subtract from 1. Thus, the area is 0.10. Fourth step, Find the t-value by finding the intersection of the right tail area, column, and the row for the degree of freedom. The desired t-value is in the body of the table. Look for the corresponding area or probabilities column heading to t sub 0.10 and locate it with the degree of freedom that is 5. Then that is the value of our t-value is 1.475884. Last step, identify if the t-score is positive or negative. Since the 10th percentile is lower than 50 and it lies below the mean, the t-score must be negative. Thus, the 10th percentile has a t-score of negative 1.476, which signifies that 10% of the values lies below it and 98% of the values lies above it. Let's have another example. Calculate the 90th percentile from the value of the lower cumulative distribution of the student's t-distribution when the sample size is 11. Let's have the solution. First step, list the known facts of the problem. That is, 90th percentile, n is equal to 11, degree of freedom is equal to n minus 1, that is 11 minus 1, that is equal to 10. So the value of our degree of freedom is 10. Find the second step. Find the area associated with the percentile by dividing it by 100. Since we have 90th percentile, that is 90 divided by 100, which is equal to 0.90. Third step, identify the area probability that is higher or lower than 0.50. If the percentile is higher than 0.50, subtract it from 1. Since 0.90 is higher than 0.50, it must be subtracted from 1. Therefore, we have 1 minus 0.90, that is equal to 0.10. 0.10 is the area of the right to the 90th percentile. Fourth step, find the t-value by finding the intersection of the right tail area, column, and the row for the degree of freedom. The desired t-value in the body of the table, look for the corresponding area or probabilities column heading to t sub 0.10 and locate it with the degree of freedom that is 10. The t-value is 1.372184. Last step, identify the t-score that is positive or negative. Since the 90th percentile is higher than 50% and it lies to the right of the mean, the t-score must be positive. Thus, the 90th percentile with the sample size 11 has a t-score of 1.372184, which signifies that 98% of the values lies below it and the 10% of the values lies above it. Let's have a practice exercise. Number 1. If the sample size is 25, then the degree of freedom is 24. Is it true or false? Very good, it is true, because we have a formula degree of freedom that is sample size minus 1. That is 25 minus 1. That is equal to 24. That makes our answer true. Number 2. 90th percentile can be written as 99 over 100 or 0.99. Is it true or false? Very good. The answer is true. Number 3. The percentile increases when the sample size decreases. Is it true or false? Very good. It is true. Number 4. 90th percentile means that the number where 90% of the values lie below it and 10% lie above it. Very good, it is true. Number 5. The area of the region to the left of the 20th percentile is 0.75. Is it true or false? Very good, it is false. 0.75 makes the statement false. It should be 0.25. If you have a question or clarification, don't hesitate to message me in my messenger account, that is Kim Francis Season Alam. Thank you! Till next video lesson. Bye!